My name is Michael Clark. I am the Director of Field Engineering at Rogers O'Brien. A little bit about myself. I've been in the industry for 20 years, a little over. I started right out of high school, so I did not go to college. I'll get that out in the open right now.
Yes.
Like many of you, my senior year, I was sitting there wondering, what in the heck did I actually want to do with my life? And I knew college probably wasn't for me. Not because of grades or anything like that. I was more than intelligent enough to go to college, but big one, funding. I know that's still a big one right now. I think I'm more about to go to college too. But also, I didn't really have a desire to spend 4 more years sitting in a class to get a degree. My passion was always creating, building, work with my hands, being outside. So I was actually fortunate enough to be able to get into the construction industry right out of high school, working for a very large firm. And it's worked out great for me. Dude, I have a really good work ethic. I was always willing to learn new things. Anytime someone came to me saying, hey, you want to learn whatever, you want to learn how to run a laser scanner, you want to learn field engineering, you want to learn how to fly a drone. I was always raising my hand, first one, right here. Constantly wanting to learn and showing up with the ambition to do better, not just showing up for a paycheck. Because of that, I've worked my way up to managing 26 people, my own department. Rogers O'Brien does about $850 million worth of work a year. So I manage all of our layout across the entire company. That's 5 regions: Austin, Dallas, Waco, San Antonio, and Houston. Emerging a little bit in College Station, but yeah. So all that just based off work ethic and the ability to learn and the desire to learn. All right. A couple other things about me. One of my other big passions right now is education. All right. So I am on the board of directors for a school called the Construction Education Foundation. I also sit on their survey trade council. CEF is what I call them. CEF is a school, post-high school, that is really dedicated to the continuing education and advancement of construction professionals. They have a wide variety of construction-based technical classes, from everything from like HVAC, getting your journeyman's license in HVAC, plumbing, welding, to survey classes, to business development classes based around the construction industry. Very good school to go to if you want to get into this, get into this world. One of the other things is I've recently joined Texo's high school committee. It is a committee dedicated to inspiring and educating, people like yourselves, the next generation, to just think about a career in construction. All right. So before I get any further, I just want to get one little, just kind of adjust the classroom a little bit here. So when I talk about a career in construction, what initially comes to your mind? Like when I say, hey, you want to come be a construction worker?
You're building stuff.
Yeah. Anything else? Work with your hands, swinging a hammer all day long, kind of thing. Running a jackhammer, working in the mud and dirt.
Engineering, like some blueprint stuff. I don't know.
Okay. Well,
You go to high level.
Yeah.
I'm hoping that by the time y'all walk out of here, y'all kind of have a little bit more understanding of what construction surveying is and how we affect a job site. So, what is construction surveying? Construction surveying is essentially the process of taking information from a design and applying it to the real world, and vice versa. So what we do as construction surveyors or field engineers is we will go out to a given area, as built, or collect everything about that area. Elevations, locations of things, just collect all of that data, so that way we can then turn around and give it to the design team. And the design team will build whatever they're wanting to build, or design whatever they want to design, based around those as-builts. We then take their design and put it into the real world. Show everybody, okay, this is the corner of the building. This is the column.
Yeah, there should be one more.
Yeah. One more.
Okay. All right. Is it Steve?
Yes.
Okay. All right.
And yeah, just put it back out into the rule. Seems like a simple process. There's a fair amount of math involved with it, but we'll go into it. So, this is what I call the boomer method of field engineering construction layout. Very, I don't want to say old school, but it's hasn't seen a lot of advancement since the days of Lewis and Clark. So, this process requires 2 or more people to go out to a job site with an instrument, this one right here, similar to this one I got standing up here. And this instrument is actually designed to measure angles and distances and triangulate accurate positions based on known locations. So we have a known location in the field, we can set up on it, and given that known location, I can now tell you everything else out there in that area. Very time consuming, and you see you got people on the side of a building, it's kind of a pain. Working out in the heat, all that fun stuff. Well, this is how I do survey. This is how we're going to it over the next probably 2 years. This will be your survey crew. A lot more robotics, a lot more technical stuff, and more automation. That's the goal. More automation. There we go. There she goes. So, anyone in here in the drone program?
None of these. Some of them were last year.
Okay, well,
So,
those of you interested in drones, you might want to pay close attention to this video right here. And I'm sure everyone here could probably recognize this site.
where are they? Yeah. Shut your face.
So this is all done with a drone 200 feet in the air. This is what we call drone survey. So drone surveying is just what it sounds like. Doing our survey, but instead of something like this, we do it with a drone. This saves tons and tons of time. Instead of going out there with this instrument and spending probably a week trying to survey this site, I did all this in 40 minutes with just me. From this information, we can pull contour lines, point clouds. So these point clouds, these are all little points that it generates in this program that we can use to create a 3D model of this entire building and surrounding area. So, this is all done with just straight up pictures. We can take cut sections of buildings, hills, valleys, whatever you want, just by drawing a line. There's the profile of that building over there. I can pull distances. I can tell you right now that it is roughly 126 feet, 5 inches from center of home plate to center of second base. For any of you baseball kids in here.
Yeah, most of
Yeah, actually.
yeah, a lot of them are.
Yep. So if you're trying to throw from second to home, you got to throw it 126 feet, 5 inches.
My word.
2 flat tires.
We can pull square footages. So if I wanted to remodel this whole parking lot here,
And take out our turn?
yeah,
Yeah.
I know that this whole parking lot area right here is roughly 85,000 square feet. I can get volumes and cuts and fills. So if I wanted to regrade this whole area right here to an elevation of 833.62 feet, I know that I need to cut out 377 cubic yards of soil. And this will actually tell me where I need to cut and how much I need to cut in each area. Tons and tons of information in a 40-minute flight. Saves us invaluable time and really helps us, get more layout done on a project. Now, we got some more cool tools. This is called automated layout. So, instead of us physically laying something out, these are tools that, just like it says, they actually provide us with a layout. We program them, we put in the information, we tell them where they are in the world, tell them what we want to lay out, and it goes. This right here is a little robot from Civ Robotics. It'll drive around your site and paint a dot on the ground where you need to put a nail, stake, whatever you want. all on its own. You just set it up, localized, bam, has a little GPS unit on top. It's off to the races.
That's insane.
This right here, this is actually one of our job sites. This is called HP Site Print. It's kind of like what the Civ Robotics one is, but for interiors. And this will actually print lines, points, and text on the ground for you. Again, you tell it where it is in the world and on your job site, and it does the rest. These kind of tools change field engineering, change surveying, change construction. I mean, talk about, I could probably train any of you in here how to use this in a day or two. This one's really cool. This is called Civ Drone. This, you put in all the information, localize it, and it flies around on the site and drives a nail for you. You can lay out an entire civil operation from the tailgate of your truck. If you know how to fly a drone and you know the basics of surveying. Some of you guys are probably already half there.
What kind of drone is that?
This is actually a, this is an expensive one. That is a proprietary drone to them.
Okay.
This is from Hilti, it's called J-Bot. This one drives around your site, drills holes for anchors in the ceiling, and marks them up so that you can find them. No more climbing up on a ladder. And again, you just have to tell it where it is and what you want it to do.
So programming, that y'all would always give me a really hard time about.
Just because you don't teach.
You
This
can
year?
come
Yeah,
in
we
useful.
You don't teach us how to do this. Yeah. You just tell us to go do it.
That was basic programming. I
Also-
needed more intense things.
Yeah, we need more intense type stuff.
Oh, okay.
That's why the test was.
We'll try again next year.
Yeah, build us.
There you go.
Build us building programs.
Laser scan verification.
You see that?
That's basically what this thing just did. It's the same machine. It shoots millions of little points with a laser as it's turning around to get something like this. This is multiple scans, which is a fancy way of saying a 3D representation of an area in little points that are spaced about 3 millimeters apart. This one's really cool because I was actually flown out to LA for 2 days to do this scan. That was a cool experience. But we can then take this point cloud and verify it against a design document or design model, whether it's Revit, AutoCAD, 3D, 2D, doesn't matter. But I can take this, compare it with our design information, and tell you on site if what was put in, if it was installed correctly. No more, well, I think it's right, or I think some of this is right. No. Every little thing that this captures, I can then verify back to you. Alright, well, I've talked to you a little bit about how we did layout in the past, how we're currently doing it. Now I want to kind of show you a little bit of the future. This is all going to be stuff coming within the next 3 to 10 years. So about the time you guys are entering in a career, entering in an industry. This is the future of construction. And I'll say it point blank right now, surveying is the future of construction. All of these cool little robots you see up here running around doing their little thing use what we call human-in-the-loop automation. Now what human-in-the-loop automation is just kind of how it sounds. A person has to be in that loop to tell it what to do and where it's at. It's not just a press a button and let it go. It's all requires someone there to tell it what to do and where it is in the world. And guess who that person is? The surveyors or field engineers. Y'all might get a kick out of this one. I don't know if any of y'all have seen this video on YouTube or not. This is Atlas from Boston Dynamics. This is one of the new automated or semi-automated robots that they're designing. It's a bipedal robot that can work almost like a human. Again, semi-autonomous. Still requires people. So there's a lot of people out there that say robots are going to take jobs. No. They're going to change our jobs, of course. They are still going to require somebody who knows how to run. Oh, that's pretty cool. And a little parkour at the end.
Because it's just creepy.
Gotta get skilled.
So,
His wife.
Oh. this is called Icon. This is a 3D printing robot. It will, yeah,
this is
it'll
what y'all were
3D
telling
print
me
an
about.
entire house.
They send one of these to Africa.
Still, they're actually gonna send one to the moon. Yes, that's their goal. That's this company's goal, is to send one to the moon.
Where are they building right now?
They are doing a 100-home subdivision in Austin right now.
What?
Yep,
Oh man,
all 3D printed.
that's good.
It's coming.
I want to see.
Yeah, I mean, fascinating stuff. But as you can see, construction's not just swinging a hammer, digging a ditch, whatever. This is the future construction. This is what construction is gonna be to you guys. So it doesn't matter if, you know, your interests are math, like geometry, trigonometry, drones, heck, even robotics. I understand you'll have a robotics kind of class here somewhere. You know,
Maybe building.
robotics. All of those interests have a place within construction. Alright? Awesome.
Man.
Yeah, that's concrete placing smoothing. You can do an entire concrete pour with 3 people instead of about 35 like you do now. As long as those 3 people know what they're doing and where they're at in the world.